This is a continuation of lesson 1.1. I ran out of time earlier, didn't have time to do examples, and so in this we're going to go ahead and do the examples. Remember, our objective was to translate word phrases and sentences into expressions and equations. This is how we'll translate real life situations and word problems into algebraic expressions and equations. So let's review real quickly. We had 3 steps to be able to do this. The first step was to choose what variables you want to use for your unknowns. Second step is to choose an appropriate operation. And the third step was to write the representative expression or equation in an order that reflects the nature of the problem. Okay, and also we have already discussed the 4 different operations and ways you can see them worded. You should already have these written down on your study guide. And I didn't mention before, but if you're doing this away from class and you don't have a study guide, you can always write these notes into a notebook or on a sheet of paper. It's just something you're going to need to be able to do the problems until you get more familiar and get more comfortable with these phrases and terminology. So anyway, these should be written down in your study guide, along with the 3 steps should be written in your study guide. So if you didn't get them earlier, you need to rewind and pause the video and get those written down. Okay, let's begin some examples. Oh, before I do, there's one thing I left out and that we do need to talk about. It's not these. These also should be in your notes, and if you don't have them written down, write them down in your notes or study guide. But the thing that I left out was this. If there's something you want done first, before anything, if you want something multiplied or added or subtracted, or before you do a multiplication or anything else, what we do is we put parentheses around that operation, around that expression. And when you read it, that can be phrased as the quantity of whatever. And when we use the words the quantity, this phrase right here, what it's saying is that everything in the parentheses, okay, the expression that's inside the parentheses. So if you see the quantity, realize there's going to be some parentheses there, and we'll work that out accordingly. All right, let's do some examples. Example 1. All right, it says the sum of a number and 5. First thing we need to do is choose a variable to represent the thing we don't know. We don't know what the number is, so I'm going to call that n. Next thing we need to do is recognize our operation. It says the sum of a number and n. So since it's sum, it's addition. So we would just write n plus 5. And you write those down in the order that they're read. That is not one of the exceptions. The exceptions were less than, more than, added to, or subtracted from. So that wasn't, in the wording, so this isn't an exception. You just write it in the order you did it. All right, on the next one. The difference of 5 and a number. The thing I don't know is the number, so once again I'm going to call that n. Whoops. And it says right there is our operation, difference, which is, if we look at our list, of subtraction. So I'm going to do 5 minus the number. That's the difference of 5 and a number. Okay. All right. The next one will not have a variable because it doesn't have anything we don't know. But we do need to recognize what the operation is. The key word right here is sets of. If we look at our list, sets of something means that we're doing groups of them, or that it's multiplication. So this is going to be 7 times 6. And in algebra, we try not to use the x for times, so we could also write it 7 times 6, like this, with parentheses. And that's probably preferred. Another way, even though it will look like a decimal, is to do 7.6 for times 6. But remember, this right here can be mistaken as 7.6, so it's better to use the parentheses. Okay. Next problem. It says 42 sheep divided into 3 groups. Once again, we don't have anything unknown here, but the operation that's being signified is right here. It says divided into. And so what we're going to do is we're going to take the 42 sheep, and we're going to divide by 3, and that will tell how many are in each group. Okay, the next one says 4 more marbles than Jim has. Alright, this thing that we don't know there is how many marbles Jim has. And so I'm going to call that J. The operation is signified by the word more than, more marbles than. And so I'm going to write this as an addition. We need to recognize that this is the exception, okay? The exception is more than, less than, added to, or subtracted from. So instead of writing this as 4 plus j, I'm going to write it as j, j plus 4. And the reason I write it that way is because we have Jim's marbles and then we have 4 more, so I had to add 4. Okay. Next one is Vinny's weight decreased by 17. What's the thing we don't know? That would be Vinny's weight. I think I'll call that V. I could call it W, but hey, it's Vinny's weight. We'll call it V. The operation is signified by the words decreased by, which means I'm going to subtract. So my expression will be V minus 17. Okay, the next one says the area of a rectangle is its length times its width. Alright, the things that I don't know here is the area, which I'm going to call A. The length, which I will call L, and I'm going to use a cursive L, that way it doesn't look like a 1. And the width, which I'm going to call W. Okay, as far as operations, I see times, so it's going to be multiply. And there's also something here that actually makes this a sentence and not an expression. I mean, you can see it's a dot, so it's a sentence. But there's a key word right here, which means that this is going to be an equation. It has an equal. It is. The area is the length times the width. Okay, when I go to write this, I just write the way it says, area of a rectangle, and then you can put a little subscript on it if you want. I do that sometimes. Is, that would be equals, length times width. Since these are both variables, I could have also just put LW, and that would have represented length times width. Okay, now I believe I'm going to go ahead and zoom in a little bit, because I'm getting a lot of writing here, and I think maybe if I zoom in I can change maybe a little bit of the space that I have to write in. Okay, our next problem says the density of an element is, there's that word is again, I'm going to go ahead and underline that. That means it's going to be an equation, it's equal. The density of an element is its mass divided by its volume. Okay, the things I don't know here are the density. We'll call that D. My D looked like a P there, that's a D. And the mass, which I believe I'm going to call M. and the volume, which I'll call V. And if I write, oh, I need to recognize my operation, which is divided by. And now I have enough information, I can write the equation in this case. The equation will be the density is mass divided by volume. And there's our equation. Alright, next example, it says Mike's balance in his checking account is greater than $450. The thing that I don't know is Mike's balance and the operation here. I don't see an operation, but I do see something that's going to tell me this is a sentence. So it's an inequality or equation instead of a expression. This one right here is showing me that it's an inequality. So Mike's balance, I think I will call it M. And his checking account is greater than the large part of the symbol there is pointing toward the M, which is the balance. So the balance is greater than $450. Okay, and the next one says the towing capacity of the pickup is at most 7 tons. So the thing I don't know right now is the towing capacity of the pickup. But I do have this, I don't have an operation, but I do have this right here, is at most, which is letting me know that this right here is it's a sentence, which I can end up making an equation or inequality out of. So this is not an equation. It says is at most. So that means really it's saying it's the least it could be. No. It's saying that it can't be more than 7. Okay, so it's up to 7. 7, I know how we can do this. All right. Letter we will use for towing capacity is C. And we can write C is at most, meaning that C has got to be less than or equal to 7 tons. And that's the examples of one-step operations. You should be able to do the first set of practice problems now. And after the first set of practice problems, you can come back and we will go through multi-step ones. Good luck.